All right, take it away, Yuval.
Okay. So I want to demonstrate or first explain a little bit about the our suggestion for the integration between VectorDB and the RGW. First of all, the why. So, and this would really give some more context and scope of why we want to do that. So, Bitstream applications already upload their data into object stores. Could be RGW, could be S3. This is a given. This is something that's happening already, and data is being poured constantly into those stores. Now, some of this data is interesting for, or should also go into VectorDB. It could be for RAG, it could be for data scientists doing some other research uh, or different applications. Now, this could be large volumes of data because this is the nature of the data being used in data stores, in object stores, sorry. And also, this is not data that is stored somewhere and then needs to be processed like in a one-time case, because at least in our case, data is being poured constantly into RGW or into object stores. Now, what we want to avoid? We want to avoid data duplications because, again, if we talk about data that we're storing, this is large volumes of data. Duplicating many terabytes or even petabytes of data doesn't make sense. We want to avoid the changing the application that use the object store because those are applications from many kinds. Could be lots of legacy, and going to each and every application and changing their code so that they would use a VectorDB could be something which is actually practically impossible to do. And also because data keep on changing, then writing scanners or something to check what is the new data that being uploaded and taking this data and putting that into the object into the VectorDB is very costly. RGW or any object store already have data management features built into them. So lifecycle of objects, access control, authentication, authorization, policies, geo-redundancy, all of those features that might also be needed in a VectorDB are solved at scale in the object store. This is a very important slide because there are many things in the solution that we propose that are missing. Or does make sense. So this is why I want to frame what this solution is not good for. If you have a knowledge base, a static knowledge base, a wiki, and you have a one-time project of uploading that into the VectorDB, what I'm suggesting here doesn't make any sense. If you have a database, structured data, and you want to use VectorDB or to integrate that or to make sure that you have VectorDB that reflects all the relations in your database, then again, this is not our case. Our case is object store, which is by definition unstructured data. There's no joins between buckets. There's no foreign keys and like all that stuff that exists in relational databases doesn't exist in our case. So when looking for this kind of solution, this is not what we're suggesting here at all. Could also be a case of a greenfield that is built ground up to have a VectorDB in it. And in this case, maybe this is also not the case that we're trying to address. There could be a better solution. So again, I'm going back to the first slide. We're talking about an organization that already have very large amount of data being constantly poured into their object store. So Most of this presentation is going to be about the ingest or automating the ingest process. And I want to go here a little bit into the details of what the setup of the system is. And then I'm going to go into the details of what the runtime is. So we assume that we have a Ceph with RGW. I'm kind of working here in the realm of Kubernetes. So I'm talking about things like Knative. Maybe there could be a different solution. I mean, if this is going to be an AWS-based solution, then you're going to have a little bit of different constructs. But this really kind of create the general components of the system, and they could apply in a different setup as well, not just an OpenShift or Kubernetes setup. So what I'm suggesting here, you define a topic pointing to a Knative channel. Knative is one of the Kubernetes frameworks for serverless functions. And you have a bucket, you define notifications on the bucket with this topic, which means that when things going to change in the bucket, then a notification will be sent to whatever the topic is pointing to, and this is the Knative channel in this case. We have a runtime application that actually is the glue that does kind of ties all the pieces together. So we define this application in Knative, and it subscribes to a channel in Knative. It knows what the bucket, where the information is, and it knows what the collection in Milvus, where the vectors should be stored. So those are the kind of setup component, the component that we set up here. And then I'm going to show what we're doing here with the runtime. So when you upload an object to the RGW, based on the configuration that I showed in previous slides, it's going to send the bucket notification to Knative. Knative is going to spawn the serverless function, or if the function is already running, then it does need to spawn it. I mean, it has all the bits in place to do serverless functions correctly. And this application is subscribed to the channel that we defined before, and it's going to get the notification sent from the RGW from the channel. And notification has all the information about what changed, what kind of information was uploaded to the RGW, but not the information itself, only the metadata about this uploading of the object. It's going to fetch the object from the RGW, and then it's going to do the embedding. Can do that locally or based on an external model that can also reside within the Kubernetes cluster. So, for example, what we've seen is that for the text embedding, we used a model that was like 8 gigabytes. So on one hand, we don't want to use an embedding library with just an API call to OpenAI or something like that, because it doesn't make sense to send the pseudo module information outside of the cluster to the internet and for the embedding. On the other hand, if we want a scalable solution, we're going to run multiple pods that does the embedding, and it doesn't make sense that each of these pods going to be 8 gigabytes just because it needs to store the embedding model in it. So we're going to find some kind of a sweet spots there between having the model close to the application, but not to duplicate the model large amount of time in the cluster. And then once it does the embedding, then it can update the collection in Milvus. At some other time, there'll be a search app, and this is kind of outside of the scope of what we're describing here. And this search app, when it wants to do a similarity search on something, it does that with Milvus. It gets the pointer to where the actual information is, and then it can fetch it from the RGW that stores the information. So we'll see that later on, but when I say update the collection, I'm not going to actually put the object inside Milvus. Only thing I'm going to put in Milvus is a pointer to where the data is in the RGW. So that's to solve the data duplication issue. So again, we're talking about the world of Kubernetes. So we want everything to be defined as a custom resource. I mean, currently we're just doing that in kind of in a manual script, but you would see that it's very straightforward, or it's some work, but it's straightforward to convert this kind of procedural process into a custom resource definition that with the right operator can do all the configuration automatically in a way that everything kind of plays nicely together. So if we talk about this custom resource, what this custom resource is, so it's per bucket. It could be sub bucket, because when we talk about bucket notifications, we allow filters, so we can filter on the key name or tags or some metadata. So for simplicity, we can talk about a custom resource per bucket, but we can even do that in some kind of a sub bucket manner. And so one thing the custom resource will have is what is the bucket that holds the information, and what kind of bucket notification to define on it. The other thing or piece of information that this custom resource would need is the basic schema we're going to have is the collection in Milvus that matches this bucket. So each bucket is going to have like a matching Milvus collection. In a very simple way, this collection is going to have just two fields. One is the vector, and the second field is the S3 object URL, so where to get the actual information from. There are other pieces of information that we need in order to do that properly. So the dimensions of the vector, the index type, the metric, and in the future, we may add more columns to the schema based on object tags, object metadata. So these are pieces of information that exist in the object. They're sending notifications, so we know them. Or during the embedding process, in some cases, you can extract features from the data itself, and those can also go into fields. So this is kind of an addition that might be necessary in many cases. But basically speaking, the only thing that this collection has is a vector, which is the key, and the S3 object URL, which is the pointer to the data. This custom resource will also have to hold the embedding function. So as I said before, we don't want the embedding function to be just an API call to web servers. We may not want that to be completely local, so we need to find the sweet spot there. The embedding may also do chunking, and I'll explain that later on. And the embedding may also add more fields. As I said, it could be something already know, like object tags, or it could be something that is extracted from the data in the process of embedding. So what do we have there? So we have Milvus. We select that as a vector DB. In the future, we may add more options like pgvector, LansDB, which is an embedded vector DB. Milvus is deployable using a Kubernetes operator. Its Kubernetes operator is not great in the sense that, I mean, for example, in Rook, you have lots of mechanisms in place. So a client can nicely query Rook to know what is the actual bucket name and service name and all that stuff. In case of Milvus, it's a little more tricky. They don't expose that nicely in custom resources, so there'll be more work there. We use Knative as a serverless framework, and we use Rook to deploy Ceph. Rook supports bucket notification, so this is easy to configure. Currently in demo, we use in Knative the in-memory channel. We should probably switch to Kafka, but it doesn't change much. And we have the application, which is what is invoked by Knative when a bucket notification is received. So I'm going to move to the application. So currently it's written in Python. Probably we should go to Golang for performance reasons. And what this application does when it gets a notification, it fetches an object from the RGW. It creates a vector embedding. Now, chunking could be supported quite nicely. I mean, you will have to write the logic for the chunking, but because we have range, we can add like a fetch by range from the RGW or any S3. Then we can just store the range as part of the pointer to where they get the data from, and create an entry in the collection per chunk, and not for the entire object. Depends with the size of the object and the nature of the data and so on. So this is also an option. The application creates a Milvus collection based on the configuration that I showed before, if it doesn't exist. And it adds the embedding and the object URL to the collection. And as I said, in the future, we might want to add more fields to the collection, like object tags, metadata, or features that are extracted from the data itself. So one second. So this is really the intro for what we present here. There's a separate discussion that maybe I want to do later on about the search API. But I would like to stop here and first, get some questions before we go on. No questions? Okay. Jiffin, are you on the call? One second. Jiffin, can you do the demo?
Sorry, I still have the network issue. I don't have the image ready, like download an image in my machine. I can. So if you can do the, I can mention the steps. If you can do it in a step, then yeah. Hello, am I audible?
Yeah. Yes. Okay. No, I'm not sure I have a setup ready for that. Maybe we can. Maybe we can go through some of the code, but that will be pretty much iterating what I presented in the slides.
Yeah. Sorry for that. Like I had like the broadband network was gone, and with mobile data, I was not able to download the image properly. That's the issue, and I was not able to do the setup.
Okay. Okay, sorry about that. Yeah, I guess we'll stop here. I will maybe I'll schedule the actual demo itself for another meeting. Again, if we'll be able to share the slide and also share the link to the repo where the actual demo code is for anyone that is interested in actually looking at the YAMLs and the Python code that runs that.
Yeah, I can also share a demo of the coding as well. Like with this if I have like along with the details.
Okay. Okay. Yeah. So if no questions, then I'm done here. Thank you.
Thanks, Yuval. Thanks, Jiffin. Anybody have, if not questions, then comments about it? All right, let's move on with the agenda.
And there is one hindrance.
Oh,
Not for the question, I think I missed some part, so I'll maybe revisit the PR. It looks interesting though, the idea. Thanks, Yuval.
Okay. Thank you.
Um,
all right, next on the agenda is Sina to discuss a GitHub PR.
Yeah, it's just about the resharding for the version buckets. I was wondering if if that could be a solution for that, because currently dynamic resharding doesn't work for uh, version buckets, and it just needs a manual work. So wanted to hear that if that could be a possible solution. Any feedbacks? Send the PR here also, in case.
Okay, yeah, this reminds me of discussions we've had about this.
Right.
Versioned buckets in particular can get large OMAP warnings because they have extra keys that aren't accounted for. And so this adds a multiplier.
I mean, to work around, I remember we did something with Archive Zone to reduce the max shards to something under 50K, I think like about 50K, so that we also have enough objects to account for. We have enough window to account for the objects that don't count.
I guess so. Then that can probably be an option, because you've done it also for the archive to reduce the max object per shard. So that can be a trick here to work around this problem. Other than that, we need to probably somehow count the number of index entries, which would be a different story.
Yeah, I see that this was suggested by Eric. So yeah, I don't know.
Okay, right, yeah, Eric was had some comments on the tracker issue. Should we assign him for review on the PR?
I think that would be good, because I think it intersects other stuff Eric's working on potentially as well.
Sounds good. This seems like a good approach to me, because, like you said, tracking precisely the number of OMAP entries is tricky.
Yeah. Okay. All right. Thank you. That was just I wanted to hear feedbacks on it.
All right, moving on, but still about reshard. Just an update on my work on parallel resharding. I have a draft PR that's open and passing reshard tests, but it depends on a lot of stuff in other PRs that need merging or cleanup. This version is using stackful coroutines, but we had discussed trying stackless coroutines here. There are still a couple of obstacles to doing that. The two bullets here are about RGW concurrent IO, which is a CLS thing that sends requests to every shard at the same time. But that blocks on a condition variable waiting for the replies. So we can't use it in the coroutines. I have a PR that adds async interfaces to do that. It only has examples for 3 of the ops at the moment, but I think that's a workable solution. The other main obstacle was reads and writes of bucket metadata. It turns out that there's a whole lot of code involved in doing that stuff. And calling from C++ 20 coroutines would, I think, require us to write coroutine versions of all of the functions that it needs to use. I brought this up in an earlier call. Not really sure how to avoid duplicating interfaces like that for coroutine and not. It just, to me, doesn't seem like a scalable way to do development. For a reshard, though, I'm thinking that maybe we just spawn a stackful coroutine to wrap those calls only, so that we have a way to call them from coroutines, even if it's not perfectly efficient, I guess. But in the reshard case, I don't think that's especially important. But I do want to find a way to make progress adopting stackless coroutines, and I guess NeoRados more generally. And NeoRados stuff, I think, has a similar problem where we need, in the meantime, librados versions of functions and NeoRados versions. And I'm not really sure how to manage that.
Well, so I think the plan of doing it a subsystem at a time is good. I don't necessarily think we need to decide that right now. Like, I don't think you need to decide that for the parallel resharding thing. I think it's good to just get the parallel resharding done. But I do think there are ways forward. Like, but I don't think we need. I do think there are ways forward, and I guess I still feel like the first step is just to finish getting rid of all the null yields, since that's sort of the main big obstacle. So, like, I think we can at least agree on. I think we can at least agree on that as a starting point, as a thing that, like, if we want to go all stackless coroutines, we can all agree that no null yields is the thing we want, and I think that's a thing that we can already like have multiple people working on. And then once we have no null yields, it'll be that's something where I don't think we'll need that much duplication of code. We're basically just making sure there's a yield context at the top everywhere. And then once we do that, then I think stacklessness becomes a lot more tractable automatically, since we aren't already caught up on the null yield problem whenever we try to think about it.
Okay. It still sounds challenging to do this subsystem by subsystem though if we have
Some
mean,
I feel like either some duplication or some wrappers are going to be unavoidable, but I feel like subsystem by subsystem, like we have more control of where it is. And once we nibble at the subsystems, then that sort of changes the dynamic of what needs what. And I think that makes it easier for us to like. I feel like once we start getting some things in, then it will become easier, I guess. Like if we do one system, then I feel like the next subsystem will be easier. Like we could pick the easiest one. Like I feel like the easiest subsystem to pick might be an isolated task like one of our long-running threads, like life cycle or something like that. I think might be like if we wanted to have the lowest possible hanging fruit to neo-rado something, I think we should look at all of our thread tasks, pick the simplest one of those, make that thing one. I think we can get that in. I think we can get that done and get that in fairly quickly.
okay. And in the process, we would duplicate all of the calls that it needs.
I think we would either duplicate or wrap, one of the two. We can figure out which, but I feel like that's the thing we do. Like we duplicate one subsystem, we try to figure out whatever the least complex way to make sure the code doesn't get out of sync. And if we can figure that out, and I think between you, me, and like everyone else, we can figure something out. I feel like once we get like our prototype in, that will make it easier to see where we're getting next. And I think we just need to we need to find the simplest prototype. Like multi-site really is big and complicated and interacts with everything. I'm not saying it shouldn't be our priority because it should, but I am saying that it might be a bit much for the first example. Like
you could still pick metadata sync. I think you had already started on that.
I had, but I kept getting hung up and onto other projects and other stuff like that. I think it's a good first project. I don't think it's that hard, but it does have a lot. I feel.
But it actually has coroutines.
It actually has coroutines.
So there's that.
You're not wrong, but let me go through our long-running threads. You go through if we could go. So what are the long-running threads we have, and what is conceptually the simplest?
So just one question. You said instead of duplicating all this function, wrapping them. How can you wrap them in a way that they would work as a C++20 coroutine and as a regular function? I don't understand how this is possible.
We can't wrap it for null yield. If we can get the null yield case out of there, then you can call from a stackful coroutine to a stackless coroutine or vice versa. There's an overhead cost, but if it's not in the middle of a loop, it may be worth paying if we can avoid a duplicate. If it's in the middle of a loop or we're calling it a lot, then I think we might have to duplicate or do something weird with templates. But I think what we do is we get all the null yields out of one thread. And once they're all out of that one thread, we can try the coroutines, and I know we can wrap C++ 20 coroutine to stackless coroutine. It's C++ coroutine to null yield. Then we also can wrap, but it sucks more, I guess.
Yeah, when I mentioned reshard and bucket metadata, that's what I had in mind, that reshard could spawn a stackful coroutine in order to make those calls. So that's the wrapping. I would really prefer to avoid adding overhead like that to RGW's request processing. Background threads are probably fine.
Yeah, that's why I'm thinking back. I think background threads are a good start for that reason too.
Maybe you can have a look at the notification thread. I mean, it is using
notification thread, you say?
Yeah, the notification manager. It is using. I mean, it has its own thread. It's a background thread that uses the boost stackful coroutines. I don't think I ever use any null yield. I mean, I use optional yield, but I don't think it should be null in any of the cases. And it has a couple, I mean, it covers a couple of the features that we want from a coroutine infrastructure, like timers, like doing a whole bunch of work and then waiting for the whole bunch of work to end, all kind of things like that.
All right, I will take a look at that and see how complicated it is, and at least see if I think it's tractable. I imagine everything is tractable with enough energy, I guess, and time.
Yeah.
Tractable with the amount of energy and time we have. But I think that's a good idea for a start, at least. If it doesn't have any null yields in it, like if you're not actually explicitly using null yield, then that makes it a perfect candidate, I think.
Yeah, I think the maybe reason why we didn't propose that to begin with is that it doesn't use the old coroutine framework. It uses the stackful coroutines, which we kind of like. So this is why we didn't think of starting from there. But other than that, it should be pretty close component. It doesn't touch all of the place and so on.
And even with stackful coroutines, we could still switch everything from librados to neorados. That should be fairly easy.
Yeah, I don't see any issue there.
All right, so I think from what you say, the notification thread might be a good place to start. Might be a good place to take our first nibble to really start getting things in.
Mm-hmm.
And we can even parallelize that. I can do the notification thread, or someone else can do the notification thread, and I can look over their shoulder and give guidance if anyone wants to volunteer to try it. Casey, were you volunteering, or were you agreeing that that's a good idea?
I think it's a wonderful idea.
All right. Casey approves of me looking at the notification thread, and so do I.
Yeah. And at least I'll be... Sorry.
I was just going to point out, Adam, that you already have kind of a working example of stackless coroutines and neorados with your data log.
That's true.
Right?
That's a good point. We actually need to... Wait, what are we waiting on? I was going to rebase that, and you were going to... I'll rebase that. I'm going to rebase that now. Could you review it, please?
Yeah, I think there were still a couple outstanding comments from my last review, but
I forgot about those. Sorry, let me handle those. Sorry. Yeah, I'll get that done today and then ping.
Yeah, I'll just say that I'm not against duplicating stuff temporarily. If we have like a strategy to eventually unify everything around stackless coroutines, but getting there is going to be a long road that we need to plan for.
I think that's reasonable, and I also think that if we have any younger junior developer in RGW that wants a thing to do, guiding them into getting rid of more than null yields would be a good there's no reason not to do that, and we know we're going to want to do that eventually. Like, if someone's saying, what do I do? We can always say, get rid of some null yields, I guess.
Yeah, I remember that Kalpesh did a lot of that at some point with Ali kind of mentoring. So if there are other people interested, then we could definitely make quicker progress. So circling back to reshard, what do people think? Should we leave that as stackful coroutines? Should we switch to stackless and wrap the bucket metadata stuff?
I think that we should do whatever will get it in faster and make switching to switching our coroutine base like a different matter. Like, whatever will make us have to write the least amount of code to get the feature done.
Yeah, I think the most important is to do this transition with the coroutines on a feature that is not fast moving and changing constantly, like reshard. try to find a quieter piece of the code to do that. Otherwise, that's not going to end soon.
All right. Matt, I know that you were pushing for stackless coroutines there. What do you think?
In which sense?
Do you think it's worth spending the extra effort to switch reshard to stackless coroutines, or
Well, in the long run, if we're successful, I would say that. But I mean, I'm trying to be agile with this process, kind of like Adam is. I mean, I'd like to not tie ourselves in a knot. I mean, there's new work going on with resharding. We can discuss it in terms of that.
Sure. And kind of going on the discussion of notification stuff, converting from stackful coroutines to stackless is not challenging as long as kind of all of the related pieces already support it. So I think starting with stackful and converting later is very tractable. Okay. Any other thoughts on parallel reshard in general? Is anybody interested in helping test this stuff? I was thinking about adding support for Jaeger tracing so that we could look at the timings, exactly how long is spent during the blocked stage versus the non-blocked one.
You see, I can help, but I think I might be a bit overloaded right now. So maybe December. But yeah, can't say yeah right now.
Cool. Okay. Well, if I do add a commit for tracing stuff, I'll be sure to tag you on it.
Sure. Yeah.
Okay. Any other thoughts on reshard? Deepika, I saw that you added keystone caching as a topic for next week. Did you want to discuss that now, or?
Okay. I thought it's for this week. I didn't check the date. I just wanted to, yeah, I wanted to discuss about it. Actually, I saw the comment from Mark. I think uh, there was a discussion earlier as well on caching and keystone caching, and yeah, I'm picking up that topic. So I just wanted to check, like, for this bug, I pasted in the. I can paste in the chat as well. Uh, I was thinking of going the mutex route, like just so there are a lot of hits, cache miss that happens when we try to like list the bucket, yeah, and just to like avoid those hits. I think if the if we add the mutex lock, maybe and the other requests cannot would get blocked. So I was thinking in that direction, and I just wanted to check. Uh, would it be a good idea, because I'm not much familiar with Keystone code right now. So any feedback would be nice to have.
Well, don't we normally avoid taking like a mutex lock and just blocking requests in a necessary request path? So I think that's a kind of a problem.
I see. That's good to know. Oh, yeah. I have to think of something else then. Yeah.
Yeah, I think we would have to, when there's a cache miss, that causes us to go to Keystone, I think we would have to add something to the cache saying that there's a request in progress with a way for other requests to wait for the result. I think that there's a very similar case with bucket resharding, where if a reshard is in progress, we'll wait and try again later. That that isn't just waiting on a mutex. So I could find examples of that stuff.
That'd be nice to have. Thanks.
I think
if
you're
it
going to
waits
need
too
something
long,
like a wait.
If it waits
gonna
too
need
long,
something that-
shouldn't it fail?
I'm sorry. Go ahead, Matt.
Well, if a short wait would be fine, but a long wait would not, right? I think.
Yeah.
The catch that you might want to, I don't think the mutex itself is a problem. The thing that you probably want to worry about is waiting on a mutex and the request times out. I don't think we really do much to look for request timing out, but potentially, I guess something could be stuck on Keystone. It might actually be stuck long enough that would be noticeable, and that would be the one case that would be interesting to catch.
Yeah. Yeah. So, do we have tests for this, or like any integration tests in pathology?
I don't know of a test, but I think you could simulate it easily enough by just firing off a bunch of requests at the same time.
Yeah, I do have. I think there's also a test case linked in the tracker. Yeah, but yeah, I think I have to first test. Yeah, maybe the process that Casey was suggesting. Mutex, I'm like a bit skeptic as well, but yeah, I can test the scenario.
So I linked the RGW Tempest Toothology suite, which does set up Keystone and run Tempest tests against RGW. So that that would at least exercise the Keystone stuff, but I'm not sure that it's going to send, parallel requests that would race that way.
Somewhere around, I have a standalone program that I used to test Swift operations at one point that should be capable of firing off a bunch of requests all at once.
It'd be nice to have as well, Marcus.
Okay. I think I put it up in GitHub at some point.
Yeah, you can also share on Slack for RGW channel.
Let's see if I can find it.
Yep. And Casey, if you have the link for the resharding, let me know.
Yeah, I'll dig something up and I can add a comment to the tracker issue. Does that sound good?
Yep. Thanks.
All right. Anything else to cover on this?
Okay. I just pasted in a link for the program that I had that tested out Swift stuff.
Oh, nice. Thanks, Marcus.
All right, great. Thanks for joining, Deepika.
Thanks for having me.
Any other topics for this week?
Hello. I just wanted to say hello, and that I was going to start working on the zone filtering and the negative filtering for bucket notifications in S3. Yeah, I think it was discussed 2 weeks ago when I was not here, when I got the time wrong. And I think Yuval gave a pretty good kind of outline of what the task should be. So I'm hoping to do that in the next few weeks.
Yeah, that's great. Great news, Alex. So we're happy to give you any support that you need there.
Awesome. Yeah, thanks for all the help so far.
Wonderful. Welcome. I've assigned the tracker issue to you.
Lovely. Thanks.
Okay, let's wrap it up here then. Thanks, everybody.
Thanks.
Thanks.
See you. Bye-bye.